of course, dy. That's my next step. Without dy, I can continue. Excellent. I have dx and I have I have dx and I have the x and dx, but I don't have the 2. Piece of cake. Multiply by 2 and divide by 2 will never hurt anyone. Good. 1/2 in front. Do not copy the limits of integration. This is extremely important. 0 to 1 are for x. So x is between 0 and 1, not y. So when the lower limit is 0, the lower limit for y will be 1. When the upper limit for x is 1, 1 squared plus 1 is 2. So this is the difference. The limits of integration are for x. When we move from x to y, for the definite integral, we never go back. This is it. The integral will become an integral in y, and the answer will be a number based on what we have here. We do not go back to the previous variable. This is it for definite integrals. So 2x dx is the dy. And x squared plus 1 to the 5th is y to the 5th. So then the answer is 1/2 y to the 6th over 6th from 1 to 2, which means 1 divided by 12, 2 to the 6th minus 1 to the 6th. 2 to the 5th is 32, 2 to the 6th is 64. 64 minus 1 is 63. 63 over 12 is divisible by 3. 21 divided by 4. Of course, with the definite integrals, and I would, especially on a test situation, I would go back and check. So either the original, I prefer the original integral. So from 0 to 1. And we had x. Careful how you enter it. It's a little bit cumbersome. So x squared plus 1, close, power 5. And then dx. Okay, so be very careful how you enter it. So when I enter it, the answer is 21 over 4, so it will be 5.125. 5.25, 21 over 4. Okay, so careful how you enter it. So again, let's dwell a little bit on the difference. Here, there are no limits of integration. The answer will never be a number. The answer is the most general antiderivative or a family of functions. If the integral is given in t, the answer must be given in t. Now, for a definite integral, I can never copy the limits of integration from 0 to 1 for x to 0 to 1 for y. No, because the limits are different. When the lower limit is x, when the lower limit for x is 0, 0 plus 1 is 1. When the upper limit for x is 1, 1 plus 1 is 2. So I get the substitution, I change the limits of integration, and I do not look back. I follow through and get the final answer, which is a number. Okay? Do not change the definite integral into an indefinite integral, change it back to x and then put numbers in. Please do not do that. Good. Now feel free to choose any problem from the definite integrals from 45 through 62. Actually, to 66. 66. Okay, so let's practice definite integrals. Please choose. And this is the end of chapter 4. And we're going to look at a word problem. But first, anyone interested in choosing or not? Anyone? Okay, I'll choose 59. And 59, the integral from -1 to 0, from x to the third dx, everything divided by 2 minus x to the fourth, everything to the seventh. Okay. I know by now you have an idea. Even if it's not the perfect one, I'm sure you have an idea by now what I am going to pick. And what are you going to pick? Anyone, please.
2 minus x to the fourth.
Absolutely. Indeed, this is the problem. Now we have to make sure that dy is in here. If not, numbers are not a problem. A factor can always be made up. Can anyone give us the dy?
Negative 4x to the third dx.
Excellent. Thank you very much. Very easy. I have this. I have this. I don't have the -4. Who cares? Piece of cake. Making up a factor, which is a number, no problem. So now the numerator is dy. The denominator is y to the 7th. And I cannot proceed before I change the limits of integration. -1/4 in front. When x is 0, the upper limit is 2. When x is -1, -1 to the 4th is 1, with minus in front, 2 minus 1 is 1. So the upper limit for y is given from the upper limit for x. The lower limit for y is given from the lower limit for x. The numerator is dy. The denominator is y to the 7th. -1/4, the integral from 1 to 2, from y to -7 dy. For definite integrals, we're not looking back. We're moving forward. So this is y to -6. So -7 plus 1 over -6 from 1 to 2. Clean it up a little bit. 1 over 24. And this is y to -6, or 1 over y to the 6th. 1 over 2 to the 6th minus 1. You can leave it as is, or again, 2 to the 6th is a 64. So -63 over 64. And I can simplify actually by 3. 21. Yes. So I'm going to rewrite it as -21 over, let me delete this, white it out. Okay, because I was able to simplify. Good. Any questions? Do we understand the difference between an indefinite integral and a definite integral? The fact that when we use a substitution, we must change the limits of integration. We don't look back. We don't have to go back to x. and we just finalize and find the answer, the number in from the new integral. Here I have no choice. I change the integral into something simple. I determine the answer, but I have to go back to the original variable. Okay. Do we need to choose other problems? Do we want to choose other problems from definite integrals using a substitution?
Can you pick one more for us to try?
Yes, yes, please. Would you like to pick, or do you want me to pick? So we can pick something with a radical, something again with a fraction, again with e in them. We can do more than one. We only
Can
had
we try 63?
63. Very good. Let's try 63. In 63, we have the integral from 0 to natural log 2, e to the x over e to the x plus 1 dx. Very nice and straightforward. Okay, let y be. I'm sure by now you have an idea. What do you think?
E to the x plus 1.
Of course. Very good. Without dy, we cannot continue. Not a definite, not an indefinite. Ever, ever, ever. Without dy, we cannot continue.
Would it be e to the x dx?
Excellent. Look how nice. Beautiful. Excellent. So then, do not copy the limits of integration. So we have dy over y. So now, the upper limit, natural log x. E raised to natural log of 2 is 2. So let me talk about this a little bit. Raised to natural log x is x. 5 raised to log base 5 of x is x. So as long as the base here and the base here are the same, and there is nothing in front, there is only 1 in front, e to natural log e, the base e, there is no need to say that. E raised to natural log x is x. When I plug in natural log 2 here, e to natural log 2 is 2 by this rule. So 2 plus 1 is 3. When I plug in 0, I get 1. 1 plus 1 is 2. So this is a property. Any base raised to log of that base of x is x. This is the general rule. Now, what happens if you forget the rule? Okay, if you forget the rule, you have to be careful when how you plug it in the graphing calculator, and the calculator will give you the answer. So, careful. E raised to power of natural log 2. When I hit enter, I have to get 2. So in case you forget the rule that I just mentioned, put in the graphing calculator. Okay, so e raised to natural log 2 is 2. 2 plus 1 is 3 for the upper limit, and I get the upper limit. For the lower limit, e to 0 is 1. 1 plus 1 is 2. Now, I continue. Which function prime is 1 over y. We had this function several times tonight. Natural log of the absolute value of y. from 2 to 3. I plug in 3 minus when I plug in 2. And if you remember the property, I could write it as 3 over 2 like this. It's a difference. Log of a applied to a quotient is the difference of logs. Okay. Do we want to work on other examples, or we're going to select a word problem now? Would you like to work on 65? Or a radical?
Can we try 62?
Yes, of course. Where is 62? Yes, of course. Good. 62. And the integral from 0 to the square root of 7, from 7x, the cube root of 1 plus x squared dx. Very good. Again, you must have an idea by now.
1 plus x squared.
Of course. We have to determine dy. Without dy, we can't continue.
Would it be 2x to the dx?
Excellent. 2x times dx. Perfect. I have my x, I have my dx, I don't have the 2. Who cares? That's a piece of cake. So this is incorporated with x and dx. The 2, the x, and the dx, they all make up dy. So the 7 goes outside. So 7 halves. Do not copy the limits of integration. So 2 and x and dx make up dy. The cube root of y is y to 1/3. Now, careful. When I plug in the square root of 7 squared, I get 7 plus 1, which is 8. When I plug in 0, I get 0 plus 1, which is 1. It would be a terrible mistake to copy the same limits of integration. This is an integral in x, which says x is between 0 and this. But y, when x is between this and this, y is between 1 and 8. So now, 7 halves, y to 1/3 plus 1 over 4/3 from 1 to 8. Flip this first, 21 over 8, and now plug in 8 minus when I plug in 1. So 8 to 4/3 minus 1. This is easy, but you can use your calculator. So the cube root first, the cube root of 3 is 2. 2 to the 4th is 16. 16 minus 1 is 15. So 21 times 15 over 8. So 1 and 2. So 315. 315 over 8. So again, I copied 7 halves. I have to increase the power by 1. 1/3 plus 1 is 4/3, and I have to divide by exact same result from 1 to 8. I had to flip 3 over 4. So 21 over 8, because 3 times 7, 2 times 4. So now, when I plug in 8, first I take the cube root, and I get 2, and 2 to the 4th is 16. So this is 16. If you have any doubts, again, you can put it in the graphing calculator. And careful how you put it in. 8 power, I like parentheses, as you already know. 4/3 so this has to be, what did I say, 16. And 16 minus 1 is 15. So that's why 21 times 15 divided by 8. Okay. Let's look at a word problem. So, for example, demand from marginal demand. So the Masterson Insults Incorporated has the marginal demand function. So this is our D prime. So this is 75. So D prime of x equals negative 2000x over the square root of 25 minus x squared. See, these problems we could have not work on them at the beginning of this chapter because we didn't know this technique called substitution, integration by substitution, where d of x is the number of units sold and x dollars per unit. Find the demand function given that d equals 13,000 when x is $3 per unit. So d is 13,000 for x equals 3. So this is a point. They're giving us an ordered pair, 3 comma 13,000. And you know why this is given to us, to find the constant C. Okay, so all we have to do find d of x as the indefinite integral from d prime of x dx, which is negative 2000x over the square root of 25 minus x squared dx. I can continue before I used the substitution and find dy, change the integral, etc., etc., etc. So I'm sure you have an idea. After
25 minus x squared.
Of course. We have to find dy, without which we cannot continue. Negative 2x dx. Let's see what we have. I have the x and I have the dx. I don't have the negative 2. Well, I can rearrange this into 1,000 and negative 2. And now I have it. I don't have to multiply and divide. So I have this, I have this, I have this. These make up the dy. So 1,000 goes outside. The integral from, again, the numerator is, so 1,000 is out. This is just this, negative 2x and dx. So this is dy. And the denominator is the square root of 1. Okay. Then I have to change it into y to negative 1/2 dy so I can integrate. So 1,000, y to negative 1/2 plus 1 is y to 1/2 over 1/2 plus a constant c. Yes, I have to go back. This is an indefinite integral. I have to go back to the substitution. I flip, so I get 2,000. And this is the square root of 25 minus x squared plus a constant c. But they're telling us that when x is 3, d is 13,000. So 13,000 equals 2,000, the square root of 25 minus 9 plus a constant c. When x is 3, d is 13,000. 13,000 equals 2,000, 25 minus 9 plus a constant c. 25 minus 9 is 16. The square root of 16 is 4. So 13,000 equals 2,000 times 4 plus a constant c. So this is 8,000 subtracted from 13,000, c equals 5,000. So we got the function. So d of x is 2,000, the square root of 25 minus x squared plus 5,000. How was this obtained again? From this indefinite integral, using this substitution, making sure that I obtained the negative 2x dx as dy, and the denominator, 1,000 goes outside, and the denominator is the square root of y. I change the square root of y into y to negative 1/2, and then this is the antiderivative. I had to flip 2,000, this plus c, because I had to go back to the variable. This is an indefinite integral. I have to go back. Once I had this, I knew I was given the fact that when x is 3, the function is 13,000. And this is the function. So 13,000 equals this, this, this. I performed the calculations. This is 8,000 subtracted from 3,000. C is 5,000. Any questions?